Hi class, in this video we'll discuss about real numbers. We'll discuss how to convert a recurring decimal into rational numbers. We'll discuss how to insert rational numbers between two irrational numbers, or how to insert irrational numbers between two irrational numbers, or how to insert irrational numbers between two rational numbers. So let's get started. Let us look what are real numbers. So real numbers are nothing but the sum of rational numbers and irrational numbers. We have already done what are rational and irrational numbers. Root 2, root 3, root 5, suppose minus root 6. These are all my irrational numbers, or you can say non-terminating, non-recurring decimals. For example, 2.10100100 dot dot dot. These are my irrational numbers. When you talk about rational numbers, any number which can be written in the form of p by q, which means 5 minus 2, 0, 3 by 7 minus 2 by 5, which means rational numbers can be divided. Now be careful, rational numbers are denoted by capital Q, irrational number Q bar, real number as R. Remember that. Now rational number can be further divided as integers and non-integers, isn't it? Non-integers like these are all my non-integers. Integers we know, isn't it? Integers are this. Now integers can be further divided as whole number. This is capital I, okay? Whole number plus W. This starts from 0, 1, 2, 3, 4 dot dot dot, and this is your negative integer, which is dot 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 minus 2 minus 1, isn't it? Now whole number can be divided as 0, isn't it? And natural numbers, am I correct or not? Denoted by capital N, 1, 2, 3. So this is the classification of your real numbers. Am I clear or not? Now let us see some properties of real number. We have already done properties of rational number similar to that. First of all, if A and B are two real numbers, then A plus B will be a real number. Then A minus B will be a real number. Similarly, A multiplied by B, again a real number, which means they are closed. These operations are closed, closure property. A divided by B, again a real number. Of course, B not equal to 0. Then law of trichotomy, which was trichotomy. What is this? That they form an order, which means if there are two real numbers, then three cases arises. A greater than B, or you can say A less than B, or you can say A equals to B. Am I clear? And between two real numbers, there are infinite real numbers. So between A and B on the number line, we can have so many real numbers, infinite real numbers. Am I clear? These were some of the properties of real number. Let us see few more properties, okay? Now look at the decimal representation of real number. I have taken 13 by 50, 10 by 3, 1 by 7 and root 2. First of all, root 2 is my irrational number. I've already solved it for you. when you find the value of root 2, you see that it is non-terminating and non-recurring decimal. Is it clear? But look at these three. These are all your rational numbers, isn't it? These are all your rational numbers. Now let's divide 13 by 50. So we'll give a point. 0 adds over here 2 times. This is 100. 30. Then we know 0. This is 6 times. Look carefully. The remainder over here is 0. Isn't it? It terminates. This is terminating decimal. Isn't it? Look at this. 10 by 3. 10 by 3. 3 times gives you 9. 1. Then point 0. 3 times gives you 9. Again 1. 0. 3 times gives you 9. Again the remainder keeps on repeating. So it goes on. So this is your non-terminating but recurring decimal, isn't it? So we can write 10 by 9 as 3.3, and the digit which is repeated, okay, we'll give a point over it, or we can say 3.3 a dash over it, which means this 3 is repeated. Look at this case. Over here, one digit is repeated. It can happen that more than one digit are repeated. Okay? For example, if you look at this one, 7. I'll give 7 1 times 7. This is 3, 0, 28, 2, then 0. And this is 6 and 0. 8 times this is 56. This is 4, 0. This is again 35, isn't it? Then over here 5 is left, 0, then 7 times 49, then 1, then 0, 7 ones are 7. Again there's a repetition, isn't it? So this entire thing is repeated if you look carefully, which means this can be written as, you know, the repeated part, you give a dash, or you can write it like that also. 0.142857, a dot in the beginning, a dot at the end, which means 142857 is repeated. Am I clear? Achha, how do you know that whether a rational number is terminating or non-terminating? It has to be recurring. Okay, non-terminating, recurring. How do we know that? Simple. We know all the rational numbers are written as P by Q. If Q is equal to 2 to the power m, 5 to the power n, where m and n belongs to whole number. If Q has a factor 2 and 5, or both, or 2 to the power something and m 5 to the power something, okay, then we get a terminating decimal. But if Q has a prime factor other than 2 and 5, then we get a non-terminating recurring decimal. Am I clear? Now let us do sums from this exercise. Okay, now look at exercise 1.3, sum number 8. 1 to 7 are pretty easy. You can do it on your own. Express in the form P by Q, of course. P and Q are integers and Q not equal to 0. 0.3 bar, 0.404040. First, we'll look at this. Whenever you are changing a recurring decimal in the form of P by Q, see that, okay, in the first step, that the recurring part is just after the decimal. If it is not, then bring it. In these two cases, the recurring part is just after the decimal. Now look over here. I'll take this as x. So I can write it like this because 3 is repeated. Now how many digits are repeated after the decimal? 1 digit. So I'll multiply by 10. You multiply by 10. If there are 2 digits which are repeated, you multiply by 100. 3 digit, then you multiply by 1000. Just immediate after the decimal. So multiplying by 10 will get 10x equals to 3.333 dot 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 dot. Now we'll subtract these two. Look over here. 10x equals to 3.333 dot 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 and x equals to 0. Now when you subtract, look over here, this is 9x equals to 3, which means x equals to 3 by 9, which means x is 1 by 3, and your x was this only, which means this is nothing but 1 by 3. So I've represented 0.3 bar as P by Q. Clear? Now look at this. Over here, 2 digits are repeated. So we'll multiply by 100. So I'll take this as x. So it multiply by 100. So when you multiply by 100, what do you get? We get 100x equals to 40.404040 dot dot dot. Now we'll subtract these two. Look over here. 100x equals to 40.4040 and x is what? 0.4040. We'll simply subtract it. So 99x equals to 40, which means x equals to 40 by 99. So this is equal to 40 by 99. In both the scenarios, we saw the recurring part was just after the decimal. Suppose the recurring part is not just after the decimal. Then what we need to do? We'll do few more sums. Okay? Now look at sum number 8 part 4 is 0.47 bar, which means the repetition is not just after the decimal. There's a digit, then the repetition. Then how to do? Look. First what we'll do, we'll try to bring the non-repeated part before the decimal. So this part is non-repeated. So suppose this is x. We'll multiply by 10. So 10x equals to 4.777 dot dot dot. In the next part, we'll try to bring the repetition part before the decimal. Okay? So this was nothing but 0.4777 dot dot. So we'll try to bring the decimal over here. So we'll multiply by 100. See? You multiply by 10, then you multiply by 100. So this becomes 100x equals to 47.777. See, we do so such that when you subtract, you need to see that the value after the decimal is same. Then only we can subtract and the value after the decimal eliminates. Okay? So just look, I'll subtract these two. These two will need to be subtracted. 100x equals to 47.777 dot dot dot. And this is 10x equals to 4.777. So when you subtract, it becomes 90x equals to 43, which means x is 43 by 90. And that's your solution. Am I clear? So 0.47 bar can be written as 43 by 90. Done. Look at this one. Similar type. 0.134 bar, which means the bar is on 34. So we can write this as x equals to 0.1343434. First, we'll try to bring the non-repeated part before the decimal. So what we'll do? We'll multiply by 10. So 10x equals to 1.3434 dot dot dot. Then we'll try to bring the repeated part before the decimal. There are 2 repeated parts. So we'll try to bring the decimal over here. So we'll multiply by 1000. So you multiply by 1000. So this becomes 1000x equals to 134.3434. See, The portion after the decimal should be same. Then you subtract these two. So 1000x equals to 134.3434 dot dot dot. This is 10x equals to 1.3434. When you subtract, you get 990x equals to 133, which means x is 133 by 990, which means this will be equal to 133 by 990. Clear? Now let us look at the next sum. Now look at sum number 12. Insert two irrational number between 2 and 3. How do you proceed? See, 2 square is 4 and 3 square is 9. Between 4 and 9 we have 5, 6, 7 and 8, and the root of all these numbers are irrational numbers, isn't it? Irrational number, we have already discussed what are irrational numbers. The root of a number which is not a perfect square is always an irrational number, and these are the numbers which are not perfect square between 4 and 9. So the root of these numbers are irrational. They told 2, choose any 2. That should be your answer. Clear? Now look at number 13. Insert two irrational numbers between 4 by 9 and 7 by 11. What we'll do over here, first change it to decimal. See, 4 by 9. So 4 by 9, you place a point 0. 9 4s are 36. 4 comes, again 0, and 4s are 30. It goes on because the remainder is repeated, isn't it? So this goes on. So 4 by 9 is actually 0.44 dot dot dot, which can be written as 0.4 bar. Find 7 by 11. Look at here. 7 by 11. So 0 point, you give 0 over here. 6 times 66. 4. This is 40. 3 times 33. 7. Again, 7 came over here, means it will be repeated. 6 3 dot dot dot, which means 7 by 11 is 0.6363 dot dot dot, which is 0.63. Now choose decimal between these two which are non-recurring and non-terminating. For example, between these two, can I write 0.50500500 dot dot dot. See, this is a irrational number. Why? Because it's non-terminating and non-repeating. Similarly, I can write 0.606006 dot dot dot. So these two, you can say these are non-repetitive and non-recurring, non-terminating rather, decimal, and they will be irrational. Clear? Now let us look at the next sum. Now look at sum number 14, very interesting. Find a rational number between root 2 and root 3. Look over here. Root 2 square is 2. Root 3 square is 3. So between these two, I need to have a number which is a perfect square. Okay, talk about 15 times gives you 225, which means 1.5 square is nothing but 2.25, and 2.25 lies between 2 and 3, and 2.25 is a perfect square of 1.5. So a rational number between root 2 and root 3 will be 1.5. Am I clear? Very easy. Find two rational number between 2 root 3 and root 15. Both are irrational. Very easy. Look over here. Same process. This is 12. and this is the square of this one is 15. So between these two, I need to find numbers which are perfect square. Am I clear or not? Okay. So you talk about 35 into 35 is 1225. So 3.5 square and of course 3.6 square, isn't it? So 12.25 and 12.96 are perfect squares of 3.5 and 3.6, and these two lies between these two, which means the numbers will be, there can be many answers. Okay, 3.5 and 3.6. Okay, now let us see. Insert an irrational number between root 5 and root 7. Very easy. See, it's so easy. Between root 5 and root 7, we have a root 6 too, and this is 6 is not a perfect square of any number, so it has to be an irrational number. Done. Insert 2, and this is the last sum, I think. Insert 2 irrational number between root 3 and root 7. See, between root 3 and root 7 you have root 4, root 5, root 6. Now look, this is a rational number because 4 is a perfect square of 2. But when you talk about root 5 and root 6, these two are irrational numbers, isn't it? Because 5 is not a perfect square of any number. So these two are my answer. Okay? Keep it till here. In the next video, we'll see the other part. Till then, take care.